All right, so on Friday, we did 5-5 and 5-6. In 5-6, we learned the last of the acronyms or shortcuts to proving triangles were congruent, which gave us now 5. Side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. So now every time that you're asked the question, are these triangles congruent? Is there enough information to prove these triangles are congruent, or they're built into a proof? You have 5 options, okay? So obviously something like a hypotenuse leg only happens for a right triangle. That's one of the ones that's kind of easy to rule out. Side, 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 you'll have no information about angles, only information about sides. So you want to definitely know these well enough that when you look at these kinds of questions, you can either eliminate some or focus in on others. But these are your 5 options. So we left off with example 2 on Friday. This says that JL bisects angle KLM. And angle K is congruent to angle M. And our goal is to prove that JKL is congruent to JML. So because we're trying to prove 2 triangles are congruent, I know it's going to be one of my 5 ways. Which is side, 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 angle, side, angle, hypotenuse, leg, and angle, angle, side. So all that's marked so far is the second part of the given. So I've got JL bisects angle KLM, and angle K is congruent to angle M. That's my given. So the K and the M are marked, right? But what does it mean to be bisected? What does that tell you? Cuts it in half. So this segment cuts angle KLM in half, which means it cuts it into 2 congruent angles, which means angle KLJ is congruent to angle MLJ. And that would be the definition of an angle bisector. So now looking at my 2 triangles, I already have 2 pairs of angles, which means I'm going to rule out side, side, side. I'm going to rule out side, angle, side. I'm going to rule out hypotenuse, leg. And that leaves me with just 2 options, angle, side, angle, or angle, angle, side. In both of those, I need a pair of sides that are marked as congruent. Is there something here that we can use to do that? Nick?
We can use JL to equal to itself.
Good. That's the reflexive side, right? So I can say JL equals JL, and my reason is reflexive. And now I've got 2 pairs of angles and the side. Is it the included side?
Yes.
Is it the one that connects the 2 congruent angles? That's how you know it's not, right? Which means it is angle, angle, side. Good. So triangle JKL is congruent to triangle JML. And my reason is angle, angle, side. And then if for some reason they gave you like JKL was congruent to LM, now you'd have angle, side, angle. So you could have actually used both, but that would have been the included side because it was not in between the 2 angles that were marked as congruent. That's why it's the non-included side. All right. Example 3 says identify the postulate or theorem that proves the triangles are congruent. So you don't have to justify each step. You're just going to the end and saying, are these congruent? And if so, which of those 5 would it be? So look at 1. I've got 150 and 150, 15 and 15. Are these congruent? And?
Angle, side, angle.
Good. Questions on that one? All right, go to 2. You've got the 90 and the 90, which not only means they're right angles, but they're also congruent. And then what other piece of information you got? Yeah. This one matches this one. That's a leg. This one matches this one, and that's the what? Hypotenuse. So this is? Hypotenuse leg. So just be careful because it doesn't always mean it's hypotenuse leg in order to prove it. What else is there? The shared side. So this could have also been what? Side, angle, side, and side, side, side. So any of those would have worked. You don't need all of them, but any of those would have worked.
On the test, let's say you give us that, if we put like, at least one of them, would it be marked?
Correct. Yep.
Test.
What?
Wait, when is the test?
Thursday. Yeah. All right, 3. What have you got going on here? Mars.
The congruent angles that like are outside are congruent to the ones inside
Why?
because they're vertical angles.
So if that was a reason, if that was a statement and proof, I would say vertical angles theorem, right? Yeah, okay. Now what?
Is it side angle side?
You could do side angle side with that information. What else?
Can you do side, side, side?
Why?
Because the middle.
Reflexive side, you could have also done side, side, side. And then just because they look like they're a right angle doesn't mean they are. So be careful. Like you couldn't have said that that's 90 degrees. You couldn't use hypotenuse leg because it's not. Unless it said something about it being perpendicular or there was a right angle. So don't assume that just because it looks like it, it works. Okay? Questions? So you are going to get questions like that on your test where it's just like that one thing. Are they congruent? And if so, why? And you have to give those reasons. And then you're also going to see the built-in proofs where you're going to have to give the steps like the one before.
We don't need to write the proofs.
No, not for just like identify. Yeah.
How many proofs are there? 2?
Remember to put that DEG and DEC are supplementary, and FAB and BAC are supplementary.
DEC. Say that again. DEC and DEG. Yeah.
Supplementary, FAB and BAC are also supplementary.
FAB and BAC are supplementary. What was your reason?
I think I put definition of linear pairs. I don't know if that was right.
Okay, linear pair postulate. I probably would have given you definition of linear pair, but a linear pair postulate is what says that they're supplementary. Yep. Then did you go from there?
Yeah, I put that DEC and BAC equal each other.
DEC is congruent to BAC, you said?
Yeah,
And what's your reason there?
I just got it.
Okay, so it is congruent supplements theorem, which says if two, let me write it before. If two angles are supplements to congruent angles, then they are congruent. If you don't remember that theorem, you could do it in multiple steps. I could say that they both equal 180, and that would be the definition of supplementary. And then I could say they both equal each other, and that would be substitution. And then I could subtract out the one that's congruent. That would be subtraction, and you get to the same thing. But obviously, that's a one-stepper, whereas what I just said would be 3 steps. Okay, so now we've got angle DE. 2, 3, 1, 2, 3. Now, is there enough information to prove the triangles are congruent? And what's your reason?
AAC.
Good. So triangle ABC is congruent to triangle EDC. Angle side. So the hardest part I think about geometry is that it is it's always compounding, right? It's cumulative. It says you have to remember vertical angles. You have to remember linear pair postulate. You have to remember congruent supplements theorem. You have to remember reflexive sides. You have to remember your properties of parallel lines and the angles that they form. Like all of that will continue to show up. You have to remember what an angle bisector is. You have to remember what a midpoint is. Like all that stuff, you are going to continue to see built into proofs. I think the triangle proofs, like of all the proofs we do throughout the school year, I think the triangle proofs are the ones that people get the most successful with, just because you know if it's ending in a this triangle is congruent to this triangle, that you have to get it to be one of those acronyms. Like you have to get it to be one of those 5. And then usually you can start to narrow stuff down. There's no right angle in this proof, so I know I can eliminate hypotenuse leg. I don't know information about, I only know one pair of sides, so I can eliminate side angle side or side side side. So hopefully that helps you out to kind of narrow it down. And then it's just gonna take some practice on these proofs to get more comfortable with them. The good and the bad is the next section is a lot of that. So in 5.7, which is called using congruent triangles, we take these proofs one step further. We say if we can prove that triangles are congruent, then I can prove that any pair of those sides or angles are also congruent. So the goal here is usually to prove the two triangles are congruent using one of your acronyms, angle, 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 side, angle, side, side, or hypotenuse leg. So you're going to first get that these triangles are congruent. And then I can state that any pair of sides or angles that was not already previously marked as congruent would be congruent because of the definition of congruent triangles. And instead of saying all of that, we say CPCTC, which means corresponding parts of congruent triangles are congruent. So CPCTC says, now if I've proven any two triangles are congruent, I can then go to any other sides that were not already marked as congruent or any angles that were not marked as congruent are congruent. So CPCTC tends to be a lot of times the last step of a proof because our goal is to prove them congruent using one of the 5 acronyms and then finish it off with CPCTC. It's not always the last one, but it is usually. All right, so this one says PR bisects angle QPS and PQ is congruent to PS. My goal is to prove that Q is congruent to S. The way I'm going to get there is to prove these two triangles are congruent and then use CPCTC at the end. So what I have already that I can mark is PQ is congruent to PS. And that PR bisects angle QPS. So what does that tell you, Kala?
That QR equals SR because the segment bisector.
That, but it's an angle bisector, not a segment bisector. So it bisects that angle, right? It cuts this angle into two congruent parts. So I would say angle QPR is congruent to angle SPR, and that's the definition of an angle bisector. We didn't write it, but this was given. Train yourself to look for things like vertical angles and reflexive side, because those are things that you can see directly from the diagram. So are either of those also here? Yeah.
For the proof, can you not say that PR and do PR equals PR reflexive and then do side angle, side, side?
Yep. Not side, but side, angle, side. You had it right the first time. So I'm going to do PR equals PR, and that's reflexive. And then the triangles are congruent. QPR is congruent to SPR, and the order of the letters could have been rearranged. And that is side angle side because we had the reflexive side and the angle between those two sides. And then we can finish it off with our CPCTC, because if those two triangles are congruent, then all the pairs of corresponding angles and all the pairs of corresponding sides that remain are also congruent. So I can say angle Q is congruent to angle S, CPCTC.
I kind of did it a different way though.
How?
I marked that like.
All right, let's do it again. So this time it says PR bisects QPS and QRS. So PR bisects the left angle and the right angle. So I would start with my given PR bisects QPS and QRS. Where can you go from there? And there's 2 places. There's 3 places, actually. One is the reflexive side, so I could use that reflexive right away. Jonathan.
QPR equals SPR.
Good. So I've got this one and this one. What's your reason?
Definition of angle bisector.
Good.
And when SRP and QRP equals everything.
Yep. So you can actually put those together in one step. QRP, SRP. So you could separate that out into 2 or 1 because the reason's the same. Are my triangles congruent? How?
ASA.
Good. QPR is congruent to SPR, angle, side angle. And if the triangles are congruent, all their corresponding parts are congruent, which leaves that RQ and RS. And that reason is CPCTC. All right, so what's given to you is WX is congruent to YZ, and ZW is congruent to XY. So that's my given information. WX, YZ, ZW, XY. What else have you got? Mars.
I put that ZX equals ZX and that's reflexive.
Good. God bless you. So is there enough information to prove the triangles are congruent?
Correct.
And?
It's side, side, side.
Good. WZ, so Y, X, Z.
You could put, for the triangles, you could put ZWX and ZYX.
Z, yes. Yeah, the order can be out of, like, rearranged. Yep. So then I get angle 1 equals angle 2. And what's that reason?
CPCTC.
Good.
That was my answer.
Good job. And 2 and 1 could be reversed, but obviously all of them had to be there. Raise your hand if you got it right. All right, good. We're feeling a little bit better about these, yes? Okay, good. Yeah. Because they didn't tell you anything was parallel. So, and you will see it, but like, let's just say that they gave you the triangles and they wouldn't have given you all the rest of that information. If they had said that the top and the bottom were parallel, wait, why did I cross through both sides? Sorry. They could say these are parallel. So if these are parallel and this is my transversal, then I could have said that this is congruent to this. And then I would have had the reflexive side. And then maybe they give you like the outsides like that. And then you would have had side angle side. That could happen, okay? Or they give you that the other sides are parallel. Maybe they give you these sides are parallel. And so these are your parallel sides and this is your transversal, which means this would be congruent to this because of alternate interior angles. And then again, maybe you had this side and then the reflexive side. Those would have both been side angle side. Or they gave you both pairs of parallel sides, or like this was also parallel. And then they didn't even need to give you the sides. You could have used angle, side angle with the reflexive side. They wouldn't have had to give you the outside ones. So if they give you parallel, you're usually using something like that. But if it's not given to you as parallel, then you can't get there yet. I could actually take this whole proof and go a step further and say that those lines are parallel. I could say that ZY is parallel to WX, and my reason would be alternate interior angles converse. So because these are congruent, I could say these are parallel. So that's like how you could see it pushed one more step. So the homework is open. The one for 5-5 and 5-6 and 5-7 are due tomorrow. We've got like 20 minutes. Let's get some progress done with those, okay? The 5-7 think that like there's a lot of just like, are these congruent and why? Are these congruent and why? Quick ones. And then there's a couple that are a little bit longer. There's one that's really long and I just want you to try it. Don't freak out, but it's a lot of, like it gives you all of the reasons and you have to build in the steps. And there's a lot of steps. So your goal is to at least just try it.
Which ones do you just work
For the 5-7, there's none.
No, for 5-5.
5-5 and 5-6, I don't think there was any either. Yeah, there's none.
I didn't.
Yeah.
That's a good thing.